Hello and welcome to another session in physics. In this session we will be looking at the topic dispersion of white light, and then we'll also be looking at the production of pure and impure spectrum and color of objects. But before that, let's review the previous lesson. Welcome back. Well, at this point, let's talk about what we mean when we say dispersion of white light. You see, light is a very special and beautiful thing. We have different colors of light, but it might interest you to know that these things are called spectrum colors. They all emanate from one color, which is white, because white has a band of wavelengths of different colors. These colors, like I said earlier, are called spectrum colors. Now, we have red. Red is the one that has the longest wavelength in air. Red can have wavelengths as long as 700 times 10 raised to the power minus 9 meters, while the color with the shortest wavelength is violet light. Violet light has the shortest wavelength of about 450 times 10 raised to the power minus 9 meters in air. It is also interesting to note that in a vacuum and in air, all the colors of white light travel at the same speed. All colors of white light travel at the same speed. But when it comes to glass, the colors travel at different speeds. It is for this reason that a glass prism is able to separate or disperse white light into its various colors or wavelengths. Now, this is a diagrammatical representation of what we're talking about here. How white light is being dispersed into various colors. We have when white light is passing through a triangular prism, there are some colors that are dispersed, which are called spectrum colors. We have red, we have yellow, orange, we have yellow, we have green, we have blue, we have violet. Now there are 1, 2, 3, 4, 5, 6 colors in number that are dispersed from white light. Now they make up what we call Roy wave here. You see them: red, orange, yellow, green, blue, indigo, and violet. Alright? Okay, so when white light passes from a source, for example sunlight, and it is incident on a glass prism, after leaving the glass prism, like we tried to explain earlier, this white light is separated into a band or a spectrum of colors or a spread of impulse colors which are formed on a screen or a wall. They consist of the 7 colors of the rainbow, like we mentioned. Sorry that in this diagram there was no indigo there, but indigo is part of the colors. We have red, orange, yellow, green, blue, indigo, and violet. They are 7 in number. The separation of the colors by the glass prism is what we call dispersion. The red color is deviated least. It is deviated least because it is the first color that has the longest wavelength, while the violet color, the one with the shortest wavelength, is deviated most. It is deviated most. Now let's see how a pure spectrum is produced. Production of a pure spectrum. The pure spectrum that we described above here, the spectrum please, we described above, is called an impure spectrum. Why is it called an impure spectrum? It is called an impure spectrum because the different bands of color overlap with each other. For a spectrum to be pure, the band of colors does not need to overlap with each other. They should not overlap with each other, and overlap should not occur. When that overlap does not occur, we have a pure spectrum. But when an overlap occurs between the different bands of colors, we call it an impure spectrum. Now, for us to avoid having an overlap, we can do that by using an arrangement of converging lens in addition to the glass prism. When you combine a converging lens to a glass prism, it helps to prevent an overlap, as shown in the diagrammatical representation here. Now look at this picture critically. You will see that from this converging lens, after light of a parallel beam, white light is focused on this prism, the parallel beam disperses the colors according to their wavelengths and spectrum, but it also has to pass through this converging lens. The converging lens, what it does now is that it focuses each color separately. It separates the color individually. That way we can have a spectrum of colors that do not overlap with each other. From our slide here, you notice too that white light from a source passes through a narrow slit. Trying to explain this picture in a more comprehensive manner, white light passes through a narrow slit and they are incident first on the converging lens, and then the slit is located at the focus of the lens, and the white light is rendered parallel as a result after refraction through the lens. Thus, a beam of parallel light is incident on the glass prism, and in this way the rays of the same color will suffer the same amount of deviation by the prism, and each color will emerge as a parallel beam. They are then brought to focus by the second converging lens. The different colors, 7 of them, red, orange, yellow, green, blue, indigo and violet, are then brought to different foci on the screen. Now let's see how colors are mixed to obtain what we call secondary colors. Note here that each color of light has its own characteristic wavelength. Every single color has its own characteristic wavelength. If the light of the yellow wavelength enters the eye will see yellow. However, if the light of green wavelength enters the eye will also see green. But if a mixture of red and green light enters the eye will also see yellow. The reason for that is because when we combine red plus green, it's going to give birth to a color called yellow. We're going to have yellow there. Yes. So all the colors that the eye can see is formed by mixing 3 basic colors. These 3 basic colors are called primary colors. They are called primary colors, and these 3 colors are red, blue and green. Red, blue and green. So when we mix any of them together, we form colors that we call secondary colors. When we mix red and blue, as you can see from the slide here, we have a color called magenta. Magenta is very close to blue, but it's more like a bright blue. And then we have blue plus green, which gives us cyan. And we have green plus red, which gives us yellow. So magenta, cyan and yellow are all secondary colors. The mixing of colored lights is known as what we call additive mixing. So all the 3 primary colors mix together to give white light. When we combine red plus blue plus green, we have the white color. This is called additive mixing. Now the operation of color movies is based on additive color mixing. Additive color mixing, that's the same principle that our televisions use, our phones use to help us see bright and beautiful colors. As you can see here, you notice how green plus blue gives us cyan, how green plus red gives us yellow, how red plus blue gives us magenta, and how a combination of green, blue and red, which are the primary colors, gives us white as well. Okay, so at this point let's talk about colored filters. Colored filters are made out of colored glass. A colored filter is a color that is able to transmit its own color, but it also absorbs any other color which falls on it. A colored filter transmits its own color but absorbs any other color which falls on it. And then we have colored pigment. An object can only be seen when light is reflected from it into the eye. So when an object is to be visible to the eye, it simply means that light has to reflect it into the eye. The substance that gives objects their color is called pigment. A pigment absorbs all colors except its own, which it reflects. So if you're seeing an object and this object is, let's say for instance, red in color, that pigment red is able to show off red because it absorbs all color except its own, which it is reflecting, and that color it reflects is what you see that appears to the eye. If a wall is painted yellow, you will be able to see yellow because it absorbs all other colors and reflects its own, which is yellow. Now black is a very special kind of pigment because black absorbs all colors and reflects none. That's why you see it as darkness. So it's not actually a color, but a pigment that absorbs all colors and reflects none. On the other hand, a white pigment reflects all kinds of colors. Colored objects such as paints used by painters can also be mixed together. When they are mixed together, we can use them to give beautiful colors to our houses. The mixing of colors pigments is known as subtractive mixing. Do well to go through the notes attached to this video for more information, and thank you so very much for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.